There are two very important things that you learned about gradient in grade 9, and in this video we're just going to kind of reason about why those facts are true. So the first relationship that you learned is that parallel lines have equal gradients, and the relationship works both ways. So lines that have equal gradient are parallel. The second thing you learned is that if two lines are perpendicular, then the product of their gradients is -1. And again, that works both ways. So if two lines if the product of the gradients of two lines is -1, then you know that they're perpendicular. So we're just going to try reason quickly about why those relationships are true. So here's the first statement we're going to try to prove to ourselves. Lines with equal gradients are parallel. So one way that we could think about it is we could say, well, so we're going to draw a bit on our knowledge of functions. We know that straight lines can be represented by y is equal to mx plus some constant. So say we have two lines, a line y is equal to mx plus b, and another line y is equal to mx plus k. So what we also know about straight lines is that when they're in the form y is equal to mx plus c, m represents the gradient. So that's why we've chosen in both cases my gradient to be m, because we've been told that these lines have equal gradients. So let's say that they're two different lines, they have the same gradient, so we know that they both are y is equal to mx plus something, right? If we assert that they are not parallel, right, so suppose that they're not parallel, then what that would mean is there's a point at which they meet, right? So parallel lines are lines that are never going to meet. So if we say that they're not parallel, that means that they're going to intersect somewhere. So there's going to be a point where the output of this function is equal to the output of this function. And the only way that that is possible is if b is equal to k. But we've said that b isn't equal to k. We've said that the lines are different. And so that would mean that the thing we assumed in the first place isn't true. That would mean that the lines must be parallel, right? So that's how we can just briefly show ourselves that lines with equal gradients are always going to be parallel. And then the second relationship, parallel lines have equal gradients. Well, we're just going to kind of reason about that intuitively, right? So it does kind of make sense that, if my lines are parallel, it makes sense that their gradients should be equal. Otherwise, you would have a line that is slightly steeper than the other, and so you would either have a case like this, right, where one line is eventually going to overtake the other, so there's going to be a place where they cross, and we said that parallel lines never meet. Or you would have them both being negative, but if they're not equal, then still one is going to be slightly steeper than the other, and so they're going to cross each other at some point. Or you could have the case where one is positive and one is negative, in which case they will definitely cross, and so they're not parallel. So it just makes sense that parallel lines can only have equal gradients. Their gradients can't be different. Otherwise, one line is steeper than the other, and so it will eventually overtake the other, which means it will have to cross over the other one, right? Then the third thing we're going to try to prove to ourselves is that lines with gradient, so say we have two lines and each of them has a gradient m1 and the other one has a gradient m2. And another property is that these two gradients multiply together give me -1. What we're asserting is that if those relationships are true, then we know that those lines are perpendicular. So this one's going to take a bit more work. So we've got two lines, right? So let's just say that m1, is equal to a over b, right? Then in order for m1 times m2 to be equal to -1, m2 would have to be equal to minus b over a, right? So a over b times b over a, that is just equal to 1. So if you times it with negative b over a, that will be -1. So we can represent the gradients of the two lines this way. And what we want to show is that if this is true, right, if these two lines have gradients that look like this, then the lines are necessarily perpendicular. And so if we just do a quick sketch for ourselves here, let's say we draw the first line cutting through, or maybe let's not draw it that long. Right, so let's draw it. Let's draw it starting at the origin, right? And let's choose the length of this arm so that this over here, the length of this, if I drop a perpendicular here, the length of this is equal to A, no, not A, B, right? So let's say this is line number 1. We know that its gradient, we've chosen to represent its gradient as A over B, which means the ratio of rise to run is A to B. For every B units that I run, I rise A units. So if I've chosen this side to be B units long, then this side would be A units long, right? And so let's call the length of this arm that joins these 2 points, let's call that R, right? So that's line number 1. Then let's draw line number 2, right? So line number 2, if M1 is a positive gradient, then obviously line M2 is going to have a negative gradient, right? So it's going to be a line that goes like this. And let's choose these dimensions so that this over here is A units long, right? And so because the gradient of line 2 is minus B over A, that means that my ratio of rise to run is minus B to A. So if I run A units backwards, I rise B units upwards, right? So so these are both right-angled triangles because it's a vertical line and a horizontal line meeting. And so that would mean that these two triangles that I've created are identical, right? If I use Pythagoras, it makes sense that this arm would also be R units long. And so what we want to show is that this angle here between the two of these lines is 90 degrees. We want to show that these lines are perpendicular to each other. How could we go about that? So we've already established that these triangles are in fact identical, even though they don't look like it, right? So if this angle is theta, right, then the angle between B and R in this triangle, so this angle over here, is also going to be theta, right? And that would mean that this angle is 90 minus theta, if you do angle sum of a triangle. And 90 minus theta plus theta is 90. And since this is a straight line angle, that would mean that this angle over here must be 90 degrees. So we've shown that those two lines must be perpendicular, right? So that means that if we have two lines and we know that the product of their gradients is -1, we also know then that they're perpendicular. Let's prove the reverse of this relationship. So if we're told that two lines are perpendicular, then we want to prove that the gradients, the product of the gradients is -1. So it's going to be very similar to what we did before, except we're starting with a different set of assumptions. So we're starting with, we're told that the two lines, so again I'm going to draw, I'll draw line 2 this way, I'll draw line 1 this way, right? We're told this time that they are perpendicular. And so what we want to show is that the product of their gradients is -1. So we'll use a similar approach, right? So let's choose the length of these lines such that they're both equal. So we'll choose them both to be R. And then I'm going to drop perpendiculars. And so I've created two right angle triangles. And if again I call this angle theta, then using angles on a straight line, I know that this is 90 minus theta. And using angle sum, I know that that would be theta, right? And so you have two right angle triangles. that have the same set of angles, right? They both have a 90 degree, they both have a theta, and therefore the third angle is also the same in size. And over and above that, they also have an equal side, one equal side, right? And so if you think back to grade 9, congruent triangles, if you have angle side, that's enough condition to show that two triangles are identical. So these two triangles are in fact identical, right? They have the same set of angles and one side equal, right? So they're identical triangles, which means that this side over here, so the side that is the other arm of theta, is going to be the same as this side, because in this triangle, this side is the other arm of theta. And this side will be equal to this side, right? And so if we call this side P, and we call this side Q, we say that it has length Q, then the gradient of line 1, so if we say the gradient of line 1 is M1, that will be rise over run. So Q, positive Q over positive P, right? So I run positive P units, I rise positive Q units. And the gradient of line 2 will be I'm rising negative P, and I'm running in the positive direction for Q units. So that would be negative P over Q. And if you times those two together, that'll be Q over P times negative P over Q, and that would just be -1. So we've shown that the gradients of those two lines multiplied together will be -1 indeed. So the too long didn't listen part of this video is basically that right? Parallel lines have equal gradients, and the relationship works in reverse as well. Lines that have equal gradients are parallel, not equal, right? That's more like it. So lines with equal gradients are parallel. And then if two lines are perpendicular, the product of their gradients is -1, and the relationship works in reverse as well. If the product of two lines' gradients is -1, then they are perpendicular. And another way that some people like to phrase the second part of our conclusions is that if two lines are perpendicular, then the gradient of the first one or the second one will be the negated reciprocal of the second one. Well, right, the negated inverse. Let's just write that properly. So what we mean by that is if we know that two lines are perpendicular and the one line has a gradient of 2 over 3, then the other one will have a gradient of -3 over 2. Or if we know that two lines are perpendicular and the one line has a gradient of -5, then the other line is going to have a positive gradient, and it's going to be the reciprocal of 5, which will be 1 over 5. So negated reciprocal is the Fancinese for that, right? Negated just means that if it was positive, it's going to become negative. And if it was negative, well, minus a minus is positive, so it's going to become positive. And reciprocal is just fancy for inverse, right? So the inverse of 2 is a half, the inverse of a tenth is 10, right? So those are the relationships between the gradients of parallel lines and the gradients of perpendicular lines.